This is a question for Precalculus, for parametric equations and parabolic equations. Earlier today at the Golf Classic Open, the professional golfer Gunter Munning hit a chip shot from the rough that just skimmed the top of a 90-foot pine tree and went into the hole, right into the hole, 220 feet away. On the green for an eagle on the 12th fairway. All right, so I've just written in the points. Where he starts, it's at 0, 0. The height of this, the vertex, it's 110. It says this, skimmed down and went right into the hole. Well, the vertex would be half the distance to where it went into the hole, half to where it lands, so that's 110. And, oh, it shouldn't have, why is there a 0 there? Wait a minute. Wait just a minute. That should be a 90. What's the height of that? At 110, the height is 90, not 0. Okay, and then at the end, after 220 feet, it's at 0. It goes back to the ground again. So I've written the 3 points. Part 1 says use linear regression, or use regression, not linear regression, to find an equation. You can do this on your TI 84 or whatever. I'm going to do it on Desmos. And I'm going to start fresh here. So I'm going to put in these values. I have 0, 0. I have the vertex, which is 110, 90, not 0, and then 220, back down to the ground, 0. Now on Desmos, I can do quadratic regression, and that is correct. That negative 0.007438, whatever. It's approximate, it's correct, but I can't get the exact decimal values that way. So I can do it this way, y1, and then tilde ax1 squared plus bx1 plus c, and now it's going to give me the values for a, b, and c, but now I can put a there and make it a fraction. So it's negative 9 over 1210, and b and make it a fraction, 18/11. So use regression to find the equation. It's going to be y equals, what was the number again? Negative 9 over 120, no, not 120, 1210, x squared, plus, what was it, 18/11? Yes, 18/11 x. And as you can see, it shows there that the c is equal to 0, which makes sense, because at 0, 0, this thing, x is 0, y is 0. Remember, it's a x squared plus bx plus c equals y. So if, oh, for some reason it's moving the slider instead of letting me write there. Equals y. So if y is equal to 0 and x is equal to 0, all these go away, and then c equals 0. So I know c is equal to 0. Now I have to find matrices. It says use matrices to find the equation. So this is 2 here, and I'm going to plug in these values into this equation. 0, 0 does me nothing except to find that c equals 0. Okay, I can plug in 110, 90. So 90 equals a times 110 squared plus bx, which is b times 110. And then I can write my last one, this last equation, 0, that's the y value, equals a times 220 squared plus b times 220. And then I can put those into a matrix. What I'm going to do is take 90 and 0 and make that into a 2-by-1 matrix, and then I'll put these values, 110 squared 110, 220 squared 220, put that into another matrix, and then I take the inverse of the 2-by-2 matrix times the solution matrix, and that's going to give me the values for a and b. So I'll do that here. You can do it on your TI. I'm going to do it on Desmos, and let me get rid of these, and then I'll show you. So I want a new matrix. A, it's a 2-by-2, and I've got 110 squared 110, and then 220 squared, and 220. And then I'm going to make a new matrix, and that's going to be my B, and that has to be a 2 by 1, and it's 90 and 0. Those are the solutions. And then I take the inverse of A multiplied by B. Notice I get decimals. I do that, and it's the very same fractions. Negative 9 over 1210, 18 over 11. Negative 9 over 1210, 18 over 11. So write the equation in the vertex form. All right, here's 3. Remember, the vertex form is y equals a times x minus h squared plus k, where hk is the vertex. Well, hk is 110, 90. And then a is negative 9 over 1210. So this is y equals negative 9 over 1210 times x minus 110 squared plus 90. All right. The next one is, what is the angle at which the golf ball takes off? All right, so to find the angle it takes off, I need to find the slope at the origin where it starts. That's where x equals 0. So I can take my equation, and if you remember what you did with derivatives, I'll use the power rule and take the derivative and then plug in x equals 0. That will be the slope of the line, or the slope of the equation rather, when x equals 0. Then I will use that to find the angle. You'll see what I'll do with that in a second. So 2 times negative 9 over 1210 is something, some number, and then 2 minus 1. This is the power rule is 1. So some number times x plus, this is already x to the first, 1 times 18 elevenths is 18 elevenths. X to the 1 minus 1 is x to the 0 is just 1. And now if I plug in x equals 0, because I want the derivative at the origin when x equals 0, I get something times 0. That goes away, plus 18 elevenths. So 18 elevenths is the slope. And check this out. I have opposite, that's the up and down distance over hypotenuse, or up and down component, and divided by adjacent, which is the x component, up and down is the y component. And what do I do when I have opposite over adjacent? That's tangent. So I'm going to use arctangent, because I want to find the angle of this slope when x equals 0 equals whatever the angle is. And it's going to be in degrees. I don't think I need that matrix anymore. It's going to be in degrees. So arctangent, make sure you're in degree mode. 18 over 11. That looks like 18 degree mode. It's about 58.6. Approximately. 58.6 degrees. Okay, what was that? All right, now here's number 5. And these things been sitting here for a long time. I wrote them and I forgot to erase them, but who cares, because now I just don't have to write them again. And I'm going to write for number 5, and I'm going to make sure I have enough room. So I'll go down a little bit and even make more room. Part 5 says, in order to introduce the parameter of time, first find the time it takes the ball to fall to the ground from its maximum height. Well, the formula to use there is height equals 1/2 times the force due to gravity times t squared. And the force due to gravity in feet is 32 feet per second. So 1/2 32 is 16. So height is 16 times t squared. Well, it says, first find the time it takes the ball to fall to the ground from its maximum height. Well, the maximum height is 90. So it's 90 equals 16 t squared. And so t equals the square root of 90 over 16, which is approximately, square root of 90 over 16 is the exact value, but square root of 90 over 16 is approximately 2.37 seconds. So that's how long it takes for it to fall from its highest height, 2.37 seconds. And then it wants, find the ball's speed when it hits the ground. Well, velocity is a force of gravity times, I think it's force of gravity times time, so that equals 32. Is it force of gravity times time? or 1/2 gravity times time. Let me check it. I have it written down somewhere here. Let's look it up. It's GT. I had it right. All right, so the force of gravity, which is 32, and then I'm going to use, well, let me do this one over here. And I'm going to use the square root of 90 over 16 to have it exact. Equals, this is going to be approximately, and this is going to be in feet per second. So 32, oh, I've got it right there, times 32 equals approximately 75.9 feet per second. Okay, so now I've got the velocity, I've got the time, and now I can do the other part of this thing, which is, let me find it here, the other part is this part. Parts is parts. And there, very nice. Okay, I've got it. I'm going to zoom. Mr. Camera, zoom. All right, it says, last use the diagram above and the information that you have found to write a parametric relation. So I'm going to have two elements of the parametric relation. I'm going to have, let's make sure this is still the right pen, it's going to be x of t equals the velocity regard to x times t. And y of t is going to equal negative 1/2 gt squared, so it's going to be g, force of gravity in regard to feet, is 32 feet per second squared. So negative 1/2 32 is negative 16 t squared. And then plus the initial velocity. Well, the initial velocity, this 75.9 I found, is a velocity when it goes back to the ground. But that velocity is going to be the same as the velocity when it takes off. Not counting for friction, but we're not counting for friction, except in the opposite direction. So technically, this 75.9 that I found for part 5 is negative, is in the negative direction. And then here it's positive, so y equals negative 16 t squared plus 75.9 t. That's the velocity with respect to y, 0 is 75.9. So I've got that one. And now I have to find what the velocity in respect to x is. Well, I know it went from 110 to 220 in square root of 90 over 16 seconds. So this is going to equal 110 to 220 is the distance of 110. Remember, distance is rate times time. So rate is distance over time. The distance is 110. The time is square root of 90 over 16, or you could put 2.37, but I don't like to round or approximate in the middle of a calculation. So this is going to be, what's 110 over square root of 90 over 16? I've got to get to my Desmos, divided by square root of 90 over 16. 46.4 approximately. Where is my, so that, oh, I've got y of t, I'm trying to get x of t, I almost put it in the wrong place. So x of t equals, what was the number again? Approximately 46.4. 46.4 t. And then y of t equals negative 16 t squared. That's the part that's taking away the velocity with the force of gravity, plus the initial velocity, 75.9 t. So that's the answer. Those are the parametric equations, and I've got all the other parts answered as well.